Okay, so let's do an example. So let's say I want to find the Fourier series. Let's talk about the trigonometric series of that function. So which is equal to x on minus 1 over 2, 1 over 2, and which is one periodic. So it looks approximately like what you have here on the right. So the first remark is that f is odd, so that we have sinus expansion, sine expansion, as if I'm trying to compute the AK coefficients, they are all going to be zeros. So let's find the BK coefficients. According to the formula, it's 1 over half a period, integral on negative half period plus half period of f of x sinus of k pi x over L. Oh, by the way, I've always written the integration by saying minus L to L, but well, the thing is that you just have to integrate on a full period. That's all that is important. So if your full period is, if it's easier for you to compute from 0 to L, that's fine. Okay, so let's write what it means for us, and we really have to understand that here the L we're looking at is half a period. So if my period is 1, half a period is 1 over 2. So that if I substitute the corresponding values in my formula, 1 over L is going to be 1 over 1 over 2, which makes 2. Integral from negative 1 over 2 up to 1 over 2 of x sinus k pi x over 1 over 2, so 2k pi x dx. So now you know that we should use an IBP in order to solve this kind of integral. So let's put u of x is equal to x, so that I will have u prime of x is equal to 1. V prime of x should be the other function, so sinus of 2k pi x, so that v of x is, well, minus cosine 2k pi x divided by, well, 2k pi. Now let's write what the integration by parts gives. So 2 times the primitive function, so minus x cosine 2k pi x over 2k pi. All right, minus, that's going to be a plus. I still have the 2. That was a factor. Integral from negative 1 over 2 up to 1 over 2 of cosine 2k pi x over 2k pi dx. Right, so that's from negative 1 over 2 up to 1 over 2. In 1 over 2, that's going to be minus 2 times 1 over 2, so that's minus 1. Then I've got so cosine of k pi times 2 times 1 over 2, so k pi divided by 2k pi minus, that's making a plus 2 times 1 times negative 1 over 2, so plus well, that's minus 1 minus cosine 2k pi 2k pi x, so that's negative 1 over 2, so the same as 1 over 2 as, so I just erase that, k pi over 2k pi. All right, plus 1 over k pi times, I get the sinus of 2k pi divided by 2k pi, negative 1 over 2 up to 1 over 2. Good news is that that second part is going to be 0 because it's going to be the sinus in k pi minus k pi. And here we get, so what do we get here? We get minus cosine of k pi is -1 up to the k, power k, and I've got 2 of those, and I divide by 2 k pi, so that's making divided by k pi, so which is actually -1 to the power k divided by k pi to the power, sorry, k plus 1 divided by k pi, right? So that's my sum, my series. You can use this notation. S of f of x is going to be given by so I can put as a factor 1 over pi the sum of -1 to the k plus 1 over k times my sinus of 2k pi 2k pi times x, right? So that's my series. Okay, and we can say that S of x is equal almost everywhere to f of x. More precisely, is equal to f of x if f is continuous in x, and to, well, the mean value. And what was the mean value? So you remember my function, sorry, looks like that. Okay, so that's 1 period. Get something like this, and that should be a 0. That should be 1 over 2 minus 1 over 2, 1 over 2 minus 1 over 2. And so the discontinuity at the discontinuity points, the function, the series, is going to actually converge to the mean value, okay, which happens to be, well, 0, right? So, and f of x is equal to 0, the mean value between f x plus and f x minus if x is a discontinuity point, and we're going to get discontinuities every time we have, well, 1 over 2 plus k, where k belongs to z, right? So that's going to be in 1 over 2, 1 plus 1 over 2, 2 plus 1 over 2, and so on. Okay, so that's for the convergence. That's important, all right? So your series converges to the function everywhere there is no discontinuity, and at discontinuity points, it's going to converge to take the value, the mean value between the two steps, right? Let us also apply Parseval equality. Oh, okay, so I remind you, what does it tell us? It tells us that the 2 norm of your function, the square of that is going to be equal to, well, a0 square over 4 plus 1 over 2 sum of the ak square plus bk square. We only have the bk, so that's going to be 1 over 2 sum of the bk square, right? So for k in n. So what does that give us? If we have defined our L2 norm to be equal to, so 1 over 2 times my half period, well, 1 over the period, minus LL of f of x squared dx. What do I get here? I'm getting 1 over 1, integral between -1 over 2 and 1 over 2 of x squared dx. So that is going to be, well, 1 over 3x3 between -1 over 2 and 1 over 2. So that's 1 over 3 times, so this is going to be 1 over 8 minus 1 over 8, so that's 2 over 8, so that's 1 over 4, so that's 1 over 12. Excellent. Okay, so according to Parseval equality, I should have that this value, this value here, the 1 over 12, should be equal to the a0 square over 4 plus 1 over 2 sum of the an square plus bk square plus, but it happens that we only have the b components, all right, so bk square 1 over 2 sum of the bk square. Okay, so the sum is on the whole of n. Okay, so what is that equal to? Let's remind us. The bk were 1 over pi times negative 1 to the k plus 1 over k. So let's write what we have here. So that should be equal to 1 over 2 sum of 1 over the pi square, we shouldn't forget that one, times negative 1 up to k plus 1 to the square, so that's going to be 1 over k square. Okay, so I've got, in the end, what do I get? I get that 1 over 12 is equal to 1 over 2 pi square times my sum of 1 over k square for k in n star, right? Okay, the bk is not is starting at k greater or equal to 1, so that I can find the value of the sum of 1 over the k square. K is in n star, and that should be given by 2 over 12, so that's 1 over 6 times pi square. Okay, and that's one of the use of this Parseval inequality. You can use that to get some nice values for infinite series. So the sum of the 1 over the squares is pi square over 6. Good.